Have you ever faced a SQL query so complicated and slow that it brought your data pipeline to its knees? Well, I know I have. Today, I'm teaming up with ChatGPT to tackle a real-world SQL challenge. Together, we're going to break it down, brainstorm solutions, and optimize it step by step. Let's dive in. So here's the scenario. We've got a query that's calculating customer lifetime value, applying discounts dynamically, and even filtering orders to business hours. This query spans millions of rows across multiple tables, and as the dataset grows, the performance has dropped drastically. Let's take a closer look. Alright, Lee, here's the challenge. This query is doing a lot of heavy lifting, and we need to improve its performance. Where do we start?
Alright, Chris, let's tackle this together. First off, let's take a look at the query's indexes. Ensuring that the columns used in joins, where clauses, and order by statements can significantly boost performance. How's that for a starting point?
That's great. Let me check the indexes first.
Perfect. While you're doing that, remember that well-chosen indexes can make a night and day difference in query performance. It's like giving your query a GPS to find the quickest route. Let me know what you find.
Okay, so to check indexing, we can do it multiple different ways, but this is a great opportunity to ask ChatGPT how we would do that. Lee, can you walk me through how to check for indexes?
Of course, Chris. To check for indexes, you'll want to look at your database's index catalog. Here's a simple way to do it in SQL Server. Select object name i.object as table name, i.name as index name, i.typedesk as index name, and column double column, c.name as column name, and s.name as column c. From sys.indexes i.object matches, sys.index columns i.column, join sys.indexes i.columns index columns on ic underscore object name and ic underscore index columns, where clauses matches, column name as column name, index name as index column name, column double column.
So that's a mouthful. I'm going to have to take a look at it. Give me just a second, Lee, okay?
No worries, Chris. Take your time. It's all about diving into the details. Just let me know when you're ready to move on, and we can explore the next steps.
Okay, so sometimes your ChatGPT, or in this case, my Lee, will give you a mouthful, and you'll have to pause them, and you could just hit the X button, and you come in here, and you'll see the query. And from here, you can copy the code directly into your SQL window. We're going to do a new query. I don't know what I just did. We're going to do a new query, and we're going to run this. And so this is why AI will not take your place. It doesn't always give you perfect queries, right? So in this case, it tells me line 14 near the parentheses, there's an issue. So here. So it gave me an example, right? So we could replace this with your table names. So it tells you explicitly what to do, right? So our table names are going to be DBO orders, DBO promotions. It's these DBO order, order details, promotions. So order details, promotions. And you'll see that there are no indexes because I just imported this data for this scenario. So we'll find that we have no indexing and we need to do some indexing. So how do we create indexes? If you've missed our video on how to create indexes, be sure you go back and check that out. I'll put the information for that video down in the description. But so we're not going to walk through exactly how to create these indexes and creating these indexes here. I don't want to waste a lot of your time if you already know how to do that. But so in this case, what we're going to do is I'm going to go back to Lee and tell him that we don't have any indexes, and he's going to give me probably a script to do that. Let's see. Lee, there aren't any indexes on any of these tables because I just imported them. Can you help me out with a suggested SQL script on creating those indexes with your suggestions on which indexes need to be created?
Sure thing, Chris. Let's create some indexes to boost that query's performance. Given your query, we'll focus on the columns used in joins, where clauses, and aggregations. Here's a starting script. Make sure to index the self-reference ID of your customer's database. This will ensure that anyone who accesses your customer database has the right index. Other indexes should be made for prominent use cases. Keep an eye out for relevant hints, but the prime target should be customer ID. Here's a starting script. Index on the customers for customer ID column used in joins, where clauses used in where clause, and aggregations used in special properties. Have a look. Okay,
so I'm going to stop him and take a look. So you'll see it created my script. We're going to copy the code. We're going to put it over here. We're going to run it, and it's going to take a second, but it'll complete successfully. So again, it speeds up your process. You'll want to be sure that you go through and kind of glance through this, make sure that you feel that they're appropriate. Indexing is more of an art than maybe a science. You're indexing on things that are going to be in your where clauses, things that are going to be in your joins, just like Lee told us. So let's move on. All right, Lee, I have those indexes set up now. Thank you so much.
You're welcome, Chris. With those indexes in place, you should see a nice boost in performance. What's our next move for this query optimization?
What do you think about the window functions in this query?
Good question. The window functions, particularly sum over parentheses, can be resource intensive. Here, we're calculating year-to-date value for each customer. If the dataset is large, this can slow things down. We could explore calculating this value in a different way, or check if it's truly necessary for our output. What do you think?
That's great. Can you tell me what line that part is on?
Absolutely, Chris. The window function sum over parentheses sum of price times hourly quantity over is located in the order summary CTE. It's around the middle of the query, where we're defining year-to-date value. Here's the line for reference. Sum of price times hourly quantity over parentheses, comma time, hourly double quote value.
Oh, there it is. So it was hidden because I collapsed a bunch of rows. Okay, so how do I... Okay, so let's expand all these back so that we don't have anything collapsed here, so I don't get confused anymore. Okay, so thank you, Lee.
You're welcome. Whenever you're ready, we can jump back into optimizing that query.
Yeah.
Just let me know.
So I found that part. Tell me how you would optimize that part.
Great. To optimize that window function, let's consider alternatives. The goal is to reduce the computational load. One way is to calculate the year-to-date value in a separate step, storing it in a temporary table. Here's a quick example. Create temporary new table. ChatLDL separates customers and their customer data. Separated values equals common data. Shoe cost times quality times quantity. Using column double column, break the year-to-date value into smaller chunks. Insert it into the query separately. Sum, price divided by quantity over time. Partisan by customer ID. Break the summing in 50-50 chunks. Separator joined, C equals C, column double column, year-to-date value, as used to join statements. Here's a simplified SQL script. Separator joined, C equals C, and column double column, year-to-date value, as used to join.
So I'm going to stop them because it will have printed out all of that already. So let's take a look. It says calculate these and store them in a temporary table. And then, so let's copy this. We're going to copy this out. We're going to put it into our query. We're going to see that it's putting it into this temp table, which temp tables are prefixed by a pound symbol. We're going to run this real quick just to make sure that it runs successfully. It does. 10,000 rows affected. And then I'm going to drop it so that it, well, we'll leave it. So then that creates our temp table, and then it is going to break down the window function for the main query. And we see that here, right? And he didn't finish because I cut him off. I'm so sorry, Lee, that I cut you off. Can you continue to print out the rest of that, the updated SQL statement with the temp table for me? You don't have to read it out loud. Just print it out, and I'm going to go and look at it.
Sure thing, Chris. Here's the continuation of the updated query using the temporary table. Customer lifetime value as select subject DO adjusted value as lifetime value from discounted orders DO undiscounted value as lifetime value from discounted orders DO undiscounted value as lifetime value from discounted orders DO undiscounted value as lifetime value.
So sometimes you're gonna run into this where, man, it because Lee wants to explicitly read everything out. And there's really no way around that right now. I'm hoping in the future they could enhance that so that you could tell it to just print it. But when you're just having a conversation, you don't want it to read out all that. So I asked Lee to go ahead and just print out the the query, the updated query, and we're gonna copy this and paste it over to our query window, just overwriting what we had. And we're gonna run that. And it's going to tell us that we already have a table named pound year-to-date values. So we're going to come up here at the top and we're going to say drop table year-to-date values. And run that. So it runs really quick. And we're actually going to take that and put it at the end of our script so that after the script, if we want to run it again, then it will go ahead and drop that and it'll recreate it each time. So, are we ready to continue our conversation with Lee now? All right, Lee. So we have done the indexing, we have done the explanation, and we have done the...
Great. With indexing, execution plan analysis, and optimization of the window functions covered, our next step could be to look at the join operations. We should ensure that our joins are as efficient as possible, perhaps by checking if we're joining on indexed columns and if the order of joins can be optimized. How does that sound as our next focus?
That's great. Do you have any suggestions?
Absolutely. For join optimization, here are a few suggestions. 1. Join order. SQL Server's optimizer usually handles this well, but sometimes rearranging the order of joins can make a difference. Start with the tables that filter out the most data. 2. Use appropriate join types. Ensure that you're using inner joins, left joins, etc. appropriately. For example, if you don't need unmatched rows from the right table, an inner join would be more efficient than a left join. 3. Index columns. Make sure your join columns are indexed. This can significantly speed up the join process. 4. Avoiding Cartesian products. Be cautious with your join conditions to avoid unintentional Cartesian products, which occur when every row of one table is combined with every row of another. 5. Check for functions on join columns. If you're using functions on join columns, it might prevent the optimizer from using indexes effectively.
Hey, Lee.
Hey, Chris. What's up? Need any more help with the query optimization?
Okay, so a little bit too much detail there, but Can you give us any specific feedback on the query that we're looking at as far as the join criteria? It looks like now everything that we're using for our joins, for our join criteria, is based on an indexed column, but I'm not sure about the order or the left join piece. If the left join that we're using can be potentially changed into an inner join, can you give me your recommendations?
Got it. Let's keep it straightforward. Since your join criteria are already on indexed columns, that's a great start. Regarding the join order, SQL Server's optimizer usually handles this efficiently, but it's generally a good idea to start with the tables that filter out the most data. For the left join, if you're not using the unmatched rows from the promotions table in your final result, changing it to an inner join could improve performance. This way, you only keep rows where there's a match in both tables, reducing the dataset further. Would you like to explore?
I'd like for you to tell me if you think it would be a good suggestion to remove that left join and change it to an inner join.
Sure, let's consider the left join in your query. Left join demo promotions P on FO customer ID is providing a match to your query. If the promotions table is not providing any critical information that's necessary for all filtered orders, and you're not using rows from promotions that don't have a corresponding customer in filtered orders, then changing this to an inner join would indeed be beneficial. It ensures only matching rows from both tables are returned, potentially reducing the result set size and improving query performance. Do you think the promotions data is essential for all customers in your final result? If not, switching to an inner join could be a good move.
All right, so this is where your domain knowledge and your knowledge of the data comes in. This is going to be the differentiator between you and AI, right? You know, we've talked about in previous videos that AI is not coming for your job. And this is one of those reasons. You need to use your judgment here. Is a left join going to be correct? Do you need everything that's in the filtered orders and also the information for the promotional data? Because not every customer in every order in the filtered orders would have a promotion, right? So it could be that you need it to be a left join. Now here, Lee is telling us, hey, an inner join could improve efficiency, but you know the reality is that you're going to lose some data. And is that okay? So that's something that you're going to have to think about critically and logically and determine. So I'm going to ask you, what do you think we should do here? Let me know down in the comments. I'm not going to make a change here. I'm going to leave it as it is, and we're going to move forward. But I want to know what you think based on what you think is happening here. All right, Lee, I think that we are ready to rerun this query. Do you have any final suggestions?
Sounds like we're in a good spot. My final suggestion would be to ensure that your statistics are up to date on the tables involved. This helps the SQL Server optimizer make informed decisions about the query execution plan. You can update statistics with this command. Update statistics dbo.tablename. Replace table name with the actual table names. Once that's done, give your query a run, and let's see how it performs.
So we've updated the statistics on DBO order. We've just done it for the one table. That's the bigger of the tables that we're looking at here. We're going to run this. So we are running the final query. It is executing now. It takes a few seconds, but it does complete. And you'll see that it took about 10 seconds. And we have 15 rows. So that is our new query. We've walked through how to brainstorm with Lee here. We have optimized our query, and now you can see kind of why AI is not coming to take your job. It's a tool. It will help you be more efficient. It can help you brainstorm. It can help you with some practical scenarios, but it doesn't know everything. And that's where you come in. So, SQL optimization doesn't have to be super intimidating. Break the problem into smaller parts, analyze the execution plan, test solutions step by step, and make all the difference. And tools like ChatGPT here, can be a real game changer when you need a different perspective. If you've, to give you ideas that maybe you're not thinking of. We all get the little forest, can't see the forest for the trees perspective sometimes, and need that touchstone to get our minds thinking in a different direction. So, if you've enjoyed this video, be sure to like, subscribe, and hit that bell notification for our future videos. And I would love for you to drop any of your own SQL challenges and your own interactions with AI tools down in the comments. Let me know how it's going. I'd love to hear your perspective as well. Thank you so much for hanging in there with me as we walk through this demonstration, and I hope you have a great day.